Hello students, in our previous video we saw the introduction of interpolation where we learnt the formula for Newton's forward interpolation. Now here we are going to deal a problem on it. The question is, form a difference table and interpolate the value of f of x when x is equal to 4. Given the values of x are 3, 5, 7 and 9 and the corresponding value of y, which is f of x, are 180, 150, 120 and 90. Now we have to interpolate the value of for x equal to 4. That is, we have to find the value of y when x is equal to 4. For which we have to use the method of interpolation. But under interpolation, we have Newton's forward interpolation, backward interpolation and Lagrange's interpolation. Now, because we have written here Newton's forward interpolation, we obviously know that we are going to use this formula. But in the examination, when this question is asked, first of all, we have to understand what method we have to use. So, to understand that, we have to check the values of x. If the values of x are placed at equidistant, that is, it is placed in equal intervals, then we apply either Newton's forward or backward interpolation formula. If they are placed in unequal intervals, then we apply the Lagrange's interpolation formula. Now, here when we see the difference between, that is, this value is known as x0 and this value is x1 and this value is x2 and this value is x3. What is x1 minus x0? It is 5 minus 3 and the difference is 2. Similarly, what is x2 minus x1? 7 minus 5 and the difference is 2. And here x3 minus x2, that is 9 minus 7 and again the difference is 2. So we can see that the values are placed in equal intervals which are equidistant with a distance of 2. So therefore this comes under equal intervals. And for equal intervals we know that we have to use either Newton's forward or backward. If it was unequal interval, then we have to use Lagrange's method. So now we have identified that we have to use Newton's forward or backward interpolation formula. But out of these two, which one has to be used now? Either Newton's forward formula or backward. So that we have to identify, for which we have to check the value which has to be interpolated. So the value to be interpolated here is x is equal to 4. If the value to be interpolated lies in the forward of the table, that is in the beginning of the table, then we have to use Newton's forward interpolation formula. And if the value to be interpolated lies at the backward of the table, that is towards the end of the table, then we have to use Newton's backward interpolation formula. If it lies in the middle of the table, you can use either Newton's forward or backward, any one. Now let us check what formula we have to use here. If we see here, x is equal to 4 and this 4 lies between 3 and 5. Okay, so after 3 we have 4 and then 5. So it lies between the forward values of this table, which means we have to use Newton's forward interpolation formula for this given problem. Now the first step is we have to write the value of h. So what is h? Which is equal to the difference, that is the constant difference that we had, the equal interval. What was that? 5 minus 3, 7 minus 5, 9 minus 7, which is 2. So all that. So 5 minus 3 is 2. Okay, so that is the 2. And it was equidistant. So the value of h is the interval that we obtain. So the h is equal to 2. And then after this we have to evaluate u. And what is the formula for u? Already I have given in the previous video. The value of u is equal to x minus x0 by h. So let us write that here. So it is x minus x0 divided by h. Now what is this x? X is the value which is to be interpolated. So here x is equal to what? It is 4. And x0 is the first value of the table under x. So that is 3. So x0 is equal to 3. Now let us apply, substitute these two values here and obtain the value of u. So u will be equal to x minus x0. So x is 4 minus x0 is 3 divided by h. What is h? It is 2. So we have to write 2 here, which is equal to 4 minus 3 is 1 divided by 2, which is equal to 0.5. So let us always keep up the decimal values. And so we have obtained u to be equal to 0.5. So now we have found the value of u. After this, we have to draw the difference table in order to find the values of delta y naught, delta squared y naught, and then delta cube y naught, and etc. for this formula. So let us form the difference table now. Now we have formed the difference table here, where the first value will be the values of x. So what are the values of x? 3, 5, 7 and 9. So that we have to write in this difference table. 3, 5, 7 and 9. What are the next? Next column is for the y, that is f of x. What are the values here given? For 3 it is 180. So that we have to write 180. And then for 5 it is 150. So that we have to write 150. For 7 the value is 120. So we have to write 120 here. And then for 9 the value is 90. So we have to write 90 here. Now after this, now in this table this is x0, x1, x2 and x3, and this value is y0, y1, y2 and y3. Now in the difference table, the first step is we have to find delta y. So let us find that now. So now we have to write this column, that is the first difference delta y, which is this value, the second value minus the first value. So 150 minus 180. And what is that? Minus 30. Okay, negative 30, which has to be written in between these two values. So that is negative 30. Because the difference, that is 150 minus 180 is minus 30. So if you want, you can just try that in the calculator also. So if you see here, 150 minus 180. Okay. So what is that equal to? So that is equal to negative 30. So you can see that. So in a similar manner, we have to evaluate this, that is 120 minus 150. The difference is minus 30. Okay, so negative 30 we have to write in between these two values. So for your understanding, I'll just try with the calculator also. 120 minus 150. So that is equal to, minus 30. So that is what we obtain. Okay. And then now the difference between these two, that is 90 minus 120. Listen students, by mistakes, many students what they do is they do in the other way, 120 minus 90 and they write here. That is a mistake. You have to subtract the previous value from the next value, because it is like y1 minus y0, y2 minus y1, y3 minus y2. So it's like that. So 90 minus 120 you have to do. So that will be equal to 30 again with a negative sign. So minus 30. If you want, I'll just show you in this one also. That is 90 minus 120, which is equal to negative 30. So that you have to write here. After completing this, we have to do the next column, which is delta square of y. Again, that is negative 30 minus of minus negative 30. So if you want, I'll just write here for your understanding. What we have to do here is this value, that is minus 30 minus of this value. So minus 30. What will be that? Minus 30 minus into minus is plus 30. And so minus 30 plus 30 gets cancelled and you get 0 for that. In a similar way, this also, this value minus this value. So minus 30 Okay, minus of minus 30. Again, that is minus 30 plus 30, which is 0. So that you have to write here. The difference between these two values is 0. So that we are writing here. So that's all. So after this, we have to just evaluate delta cube of y. Because we need to bring it to one value. For that reason, I'm just showing you. So delta cube of y, again this minus this. So 0 minus 0 is obviously 0. So with this we have to stop. When it comes to one particular value, we have to stop the difference table. Now after stopping this, now we are doing Newton's forward interpolation formula. So we have to just put a box around all the first values of each column. So these are the first values. So you just mark it. That is, this value is y naught. This value is delta y naught. This value is delta square y naught. And this is delta cube y naught. Now these are the values that we have obtained. Now we have to take and substitute this in the Newton's forward difference formula. And the formula will stop until delta cube y. After that the formula will not proceed. So now the formula to be used is y equal to y naught plus u by 1 factorial delta y naught plus u into u minus 1 by 2 factorial delta cube y naught plus u into u minus 1 u minus 2 3 factorial delta cube y naught. We have to stop till delta cube y naught because the difference table has gone until this value only, delta cube of y. So after that we need not proceed the formula. We can stop it. So this is how we have to identify where we have to stop the formula. The till where the difference proceeds, until there we have to stop the formula. Then after that, now first in the formula, the first value is y naught. So what is y naught? Y naught is 180. So this is y naught. So that we have to substitute. So if you see here, I have written the formula here, and so the value of y will be equal to, the first value is y naught, which is 180, plus u. So what is u that we have evaluated? The value of u is 0.5. So that we have to substitute. So 0.5 divided by 1 factorial multiplied with delta y naught. Delta y naught is this second value. This is y naught. This is delta y naught, which is negative 30. So that we have to take and substitute here. So minus 30. Multiply this with minus 30. And then plus u multiplied with u minus 1. What is u? U is 0.5. So 0.5 multiplied with 0.5 minus 1 divided by 2 factorial multiplied with delta square of y naught. But what is delta square of y naught? It is 0. So we have to write 0 here. And after that, again when we do for this formula, it will also be 0 because we know that delta cube y naught is 0. So let us stop it here because the next term is also going to be 0 only. Even this term is going to become 0, but still I just wanted to show you. So I have written this. So if we write till here also, it is enough. And so that is equal to 180. And then this here we have a plus. So plus multiplied with minus. It's a multiplication. Remember that it is in multiplication. So plus into minus is minus. Then you have to multiply 0.5 with 30. So let us see that now. So we have to do 0.5 multiplied with 30. So I have given that here. Okay, so 0.5 multiplied with 30, which is equal to 15. So that 15 we have to write now. So 15 divided by 1 factorial. Actually, what is this factorial? Factorial means, for example, if you have, for example, 4 factorial, it is like 4, or you have to multiply this 4 with all its previous numbers, 4 into 3 into 2 into 1. So if it is 5 factorial means what it will be? 5 into 4 into 3 into 2 into 1. So this is 5 factorial. 3 factorial means it is 3 into 2 into 1. Okay. And what will be 1 factorial? 1 factorial you should not consider 0. So 1 factorial will be just 1. Okay, that number. If it is not possible for you to understand it, you can also do it in your calculator. Now you have to check out for factorial in your calculator. For example, we have factorial over here, but it has to be applied by using the shift because it is written here. And so, for example, if we want 5 factorial, so for that first we have to type the number 5. So type the number 5. So it has come. Now you want factorial, for which you have to press shift and then press this factorial. So you have got the factorial of shift and this, and so that is equal to 120. So this is how you have to calculate the factorial with the help of your calculator. Now we wanted 1 factorial, right? So I am pressing 1 and then shift and then this factorial. So that one. So we have 1 factorial over there, which is equal to 1 only. See here, it is 1. Okay, so this is only 1 factorial. So anyway, it is going to be 1. So any number divided by 1 is the same only. So then next we have 180 minus 15. So we have to subtract it, and what that the answer that we are getting is 165, and so the answer is 165. Therefore the value of y is equal to 165 is the answer. So hope you have understood the concept of Newton's forward interpolation method. In our next video, we will do another problem by using decimal numbers on the topic Newton's forward interpolation formula. For you to understand this concept more better, kindly follow the next video. Thank you.